Have you ever wondered what happens to glass bottles after we throw them in the recycling bin? What seems like simple waste actually begins an impressive journey, a transformation where piles of broken glass are turned back into clean, transparent and shiny bottles. Today we're going inside one of the world's largest glass recycling plants, a place where hundreds of tons of waste are processed every day to give them a new life. We'll discover how this process works, turning trash into raw materials and demonstrating why glass is one of the most sustainable materials on the planet. Recycling begins with something essential, a constant flow of used bottles. In everyday life, empty beer, wine or soda bottles often end up mixed with regular trash, making sorting them for recycling a costly and complicated process. However, in many European countries there is a system designed to solve the problem at its source. Automatic return machines are being installed throughout the city. The user simply inserts an empty bottle, the machine scans it, sorts it, and returns a small monetary reward, usually between 10 and 20 cents per container. In this way, a freshly finished bottle of beer does not become trash, but a resource with immediate monetary value. This system encourages people to collect bottles on their own, while at the same time providing factories with clean, pre-sorted and more uniform glass for processing. Europe seems to have perfected this model. But what about other regions like the United States or Latin America? Some countries are still far from reaching this level of automation, making recycling more difficult and expensive. When the return machines are full, collection companies send specialized trucks to empty them. The plastic containers, each with thousands of empty bottles, are loaded onto the vehicles using forklifts. A single truck can transport between 20,000 and 30,000 bottles per trip, which is equivalent to about 10 or 12 tons of material. From supermarkets and collection points, trucks travel directly to the recycling plant. Upon arrival, the drivers unload the cargo in a huge storage yard. In a matter of minutes, an avalanche of bottles slides down the ramps, forming mountains of different colored glass that shine under the light, greens, browns, and transparent. These piles are not waste. They are the starting point of the entire recycling chain, a reserve of raw material ready to be cleaned, shredded, and turned into new bottles. At this point begins one of the most important stages of the process, cleaning the glass. Large front-end loaders move across the storage yard, lifting enormous piles of broken bottles and fragments of different sizes and colors with their buckets. With precision, they unload all this material into the feed hopper, a massive metal structure that acts as the gateway to the heart of the plant. From there, the glass fragments slide down an inclined steel ramp and fall onto a constantly moving conveyor belt. This belt carries them into the complex, where the initial cleaning and sorting operations begin. The journey of recycled glass is not simple. It arrives mixed with dirt, dust, label remnants, plastics and even metals, so the plant must remove each contaminant before it can be reused. The first stop is an industrial vibrating screen, an enormous sieve that shakes the material vigorously. This motion automatically separates the sand, dust and smaller particles that accumulate between the fragments. The metallic clang and the clatter of glass shards against the steel mark the rhythm of this phase. When the glass comes out of the sieve, it looks visibly cleaner, although it still contains larger impurities, such as paper, lids or plastic fragments, that machines cannot always identify on their own. Therefore, the process combines technology and human labor. Along the conveyor belt, trained operators carefully observe and manually remove any non-glass items: wet labels, pieces of cardboard, bottle caps, aluminum lids, or organic waste that sometimes arrives mixed together. Each action is part of a precise choreography that guarantees the purity of the material. This collaboration between automated machines and expert hands ensures that the end result is a much cleaner, more uniform glass base, ready to continue its transformation in the next stage of recycling. It is the point at which the initial chaos of the waste begins to turn into high-quality raw material, capable of being reborn as a new bottle. Hidden among the glass fragments are still metal lids and rings. Fortunately, most of them are made of steel, which allows them to be easily removed using a high-power magnetic separator. The principle is simple. The magnet attracts the metal pieces, while the glass continues to advance on the belt. With this stage, the material is approximately 80% free of impurities and one step closer to its rebirth. Once the glass is clean, it moves on to the next crucial step: being ground. The larger pieces are fed into an industrial hammer mill equipped with rotating shafts that strike the material with enormous force, progressively reducing it to tiny fragments. Any pieces that are too large are automatically detected and sent back to the mill until they reach the correct size. This is how a uniform product called cullet is obtained, a set of shiny particles that resemble artificial sand. Cullet is much more than a byproduct. It is the heart of recycled glass. Thanks to its small size, it melts up to 40% faster than virgin materials such as sand or limestone, drastically reducing energy consumption. Next, the cullet passes through a suction system and air currents that remove any remaining labels or paper. The result is clean, homogeneous glass, ready for the most precise stage of the entire process. In this phase, the glass is dropped like a shimmering waterfall into a chamber where laser and optical sensors scan each particle at an impressive speed. The system detects its color and chemical composition, differentiating between green, amber, or transparent glass, and even identifies ceramic fragments that must be separated. When the sensor locates an incorrect particle, a precise burst of compressed air blows it into a separate stream. The process occurs in fractions of a second. Tens of thousands of pieces per minute are analyzed and classified with millimeter accuracy. This ensures that each batch of cullet is a single color, which is vital, as even a minimal mixture of shades could ruin the quality of the new glass. Finally, the sorted material is stored in large compartments divided by color, where it accumulates into huge mounds ready for the next transformation. Before being melted, the cullet must be mixed with new ingredients. The process begins with pure silica sand, which gives the glass transparency and shine. Then sodium carbonate, soda ash, is added, which reduces the melting temperature and improves energy efficiency. Limestone is also incorporated, which reinforces the glass structure and gives it greater stability. Depending on the type of product, manufacturers may add dolomite, alumina, or metal oxides to adjust color and properties. However, the most important component remains cullet, which can represent between 20% and 70% of the mixture. The more cullet used, the less energy is needed and the lower the CO2 emissions. For example, increasing the proportion of recycled glass by 10% reduces energy consumption by around 3%. With the balanced formula, the mixture is homogenized and prepared for baking. The mixture enters a large gas oven, where the temperature reaches 1,250 degrees Celsius, hotter than lava from a volcano. Technicians in fireproof suits monitor each stage, as the heat can reach 3,000 degrees Celsius in the most active areas. For approximately 24 hours, the components slowly melt into a viscous, shiny mass, liquid glass. At this point, the residual gases escape, and the material reaches the purity necessary for molding. To shape the glass, precision molds are needed. Engineers design them using CAD software, controlling every dimension in detail. Subsequently, the molds are manufactured with steel or cast iron, capable of withstanding more than 1,400 degrees Celsius. Once ready, they are installed on the double blow molding production line, a system widely used to manufacture bottles, jars, and pharmaceutical containers. The process begins when the molten glass is cut into small portions called gobs or drops, which fall into the preliminary molds. Inside, a stream of compressed air blows from above, pushing the hot glass against the walls of the mold and creating a hollow preform known as a parison. That incandescent bubble immediately passes into the final mold, where another burst of air inflates it until it fits the design perfectly. In just seconds, the bottle takes its final shape, ready to cool and solidify. Fresh out of the mold, the bottles shine with an intense red glow. Precisely programmed robotic arms lift them and gently place them onto the conveyor belt. The atmosphere is quiet, synchronized, almost hypnotic. The bottles enter an annealing tunnel where the temperature is slowly lowered to prevent fractures due to thermal stress. This process can take several minutes or even tens of minutes, depending on the type of glass. Once cooled, the bottles arrive at the automatic inspection area. There, high-speed cameras and optical sensors check each one in real time. If a defect, bubble, crack, or deformation is detected, the system immediately removes the part from the line. Then the rim or mouth of the container is checked, using mechanical probes and precision detectors. Only the bottles that pass all the tests continue onto packaging. In the final phase, palletizing robots arrange thousands of bottles with absolute accuracy. Using suction cups or clamps, they place complete rows on pallets, interleaving protective sheets between each layer. Once the stack is finished, an automatic wrapping machine covers everything with plastic film, and a label with a batch code is placed on it. The pallets are stored carefully, ready to be shipped to the bottling centers. The final destination for many of these bottles is to contain famous drinks, such as Coca-Cola. Before filling them, they undergo a thorough cleaning with hot pressurized water and steam, eliminating all traces of dust or bacteria. Then, on an automated line, precision nozzles fill each bottle with the exact amount of beverage, while CO2 is injected to preserve the characteristic carbonation. Next, a machine places the metal caps and sensors check the seal to ensure there are no leaks. Each bottle passes through a camera system that checks fill level, labels, and any cracks. Finally, the bottles are grouped into boxes, stacked on pallets, and stored in cold storage, ready for distribution to millions of retail outlets worldwide. And so, a simple fragment of broken glass is transformed back into a new shiny bottle ready to use. Glass recycling is not only an environmental victory, but also an impressive demonstration of modern engineering. Each recycled bottle represents energy saved, emissions reduced, and a sustainable cycle that can be repeated forever. Perhaps the next time you hold a bottle in your hands, you'll be touching a piece that has already had many previous lives. Recycling glass is not just an ecological act, it is a way to close the perfect cycle of one of the noblest materials on the planet.